In preparation for talking about inverse functions, we're first going to talk about one-to-one functions. Now, a function f is one-to-one when different inputs so for example, if x1 is an input and x2 is an input and they're different numbers, give different outputs. So the output for x1 is f of x1 and the output for x2 is f of x2. These are different. Whenever the inputs are different, the outputs have to be different, always. If that's the case, then we say the function is one-to-one. So here's an example of a one-to-one function. F of x equals 3 times x. So if we put an input here, let's say 4. So 4 is one of my inputs. And we calculate it. 3 times 4 is 12. And then we pick another input, let's say 6. So 6 is another input. And f of 6 is equal to 3 times 6 is 18. Now we see that we have different inputs, 4 and 6 are different, and the outputs are different, 12 and 18. So different inputs give different outputs. If your function just multiplies everything by 3, then there's no way we're going to get the same output if the inputs are different. So f is one-to-one here. Now let's take a look at another function. Let's call this one g is equal to x squared. Now this function is not one-to-one. If you think about it a little bit, you could think about two different inputs for f, or for g rather. So let's say -3 and 3. Now if we calculate g of -3, you get the square of -3, which is equal to 9. And then if you calculate g of 3, it's the square of 3, which also is 9. So here we have a problem for one-to-one-ness because we have the same output but different inputs. So this function is not one-to-one. G is not one-to-one. Okay? Now sometimes a function can be given as a set of ordered pairs. So let's take a look at such a function. For example, let's take a look at the domain of the function has some numbers in it. So here's the domain. Remember, the domain is a set of inputs. And here's the range, which is a set of outputs. And the function is f. And so let's say we have the numbers 1, 2, 3, and the output has numbers 15 and 17. And we connect these as 1 goes to 15, and then 2 goes to 17, and then 3 goes to 17. So if I were to translate these arrows, I would basically say that f of 1 is 15, and then f of 2 is equal to 17, and f of 3 is equal to 17. And the issue here is these two, because we have the same output coming from different inputs. And so again, here, in this case, we would say that the function f is not 1-to-1. Okay, and let's do one more example. So in this case, the function is given by a set of ordered pairs, -3, 3, comma, -2, 2, comma, -1, 1, comma, 0, 0, comma, 1, -1. Okay? So the question is this function 1-to-1? Okay, let's say this function is called g. Okay, now this first set of ordered pairs tells us that g of -3 is equal to 3. The second set of ordered pairs tells us that g of -2 is equal to 2, etc. Okay? Now, to figure out whether this function is 1-to-1, we can just focus on the outputs. Here the outputs 3, 2, 1, 0, -1. Okay? None of these outputs are the same. And so automatically, because none of the outputs are the same, f is 1-to-1. Okay? F is 1-to-1. Now sometimes we're given the graph of a function, and we want to determine if the function is 1-to-1. So let's say we have the graph of a function given by straight line. Okay, so here's the x-axis, here's the y-axis. Okay, so if we pick two different inputs, let's say this one is x1 and this one is x2, and then if we trace it up to figure out what the output is, here's the output. This is f of x1, and then for this one I trace the output. This is f of x2. And whenever we have different inputs, we can see that the outputs are different for different inputs. So this function is 1-to-1. Now, on the other hand, let's take a look at another function. Okay, now this function is not 1-to-1. So let me select two different inputs to show you. This input over here, let's call this x1, and this input over here, let's call this x2. Now if I trace up this function on the graph, this number here is f of x1, or f of x2 rather, and then if I trace up this first point to the function, and I see that that point is f of x1. They're the same point. So here in this example we have the same output but different inputs. And so for this reason, this function f is not 1-to-1. As a matter of fact, there is an easy test that you can do to figure out if the graph of a function represents a 1-to-1 function. And that's called the horizontal line test. We'll talk about that in the next video.